Hello and welcome everyone. So, welcome to the solution for problem of the day. If I am clearly audible and visible, can I get a confirmation in the chat box? A plus one will work. Hi Rishit, hi. How are you? How is your practice going on, Rishit? Hi Agam, hi. Thank you Rishit for the confirmation. So we'll start the session in just a minute. Okay. So what about today's problem of the day? Were you guys able to solve problem of the day? nCr. The name of the question was nCr. I want to learn DSA. From where should I start? So for DSA, what you can do is you can verify. First of all, what you need to do, you need to like if you are not able to keep yourself if you are not a consistent kind of person, then you should go for a course. Else there will be a list of you can explore gigs for gigs over there. There will be a list of data structures and algorithms, and you can read down that articles as well, and on YouTube as well you will find out many YouTube videos related to how to learn DS. Okay, and there is a course available at gigs for gigs as well. You can look at the courses as well. Okay, Agam. Okay, so let's start today's session, and today's session is going to be interesting and it is going to be quick enough. Okay, so I'll be sharing my screen, and if any kind of hindrance from my end regarding screen sharing or anything, then do mention down in the chat box. Okay, I hope my screen is clearly visible. Okay, so now let's erase the solution so that uh, we can solve it. Okay, so the name of the question is NCR and the difficulty level of this question is medium. Okay, so let's try to understand what the problem is trying to say. The problem statement is not very much difficult to understand, and it's very straightforward. Just give me a minute. Let me uh, open this YouTube in my phone as well so that I can read down your chat. Just a minute. That I can read down your. Okay, so let's start. So the problem statement is very simple and very easy to understand. So let's read down the problem statement. So given two integers n and r, and what you have to do, you have to find out n combination r. So one more thing that is mentioned is since the answer may be very large, calculate the answer modulo 10 to the power 9 plus 7. Okay, so modulo 10 to the power 9 7 needs to be applied. So n combination R, I think you guys are smart enough. You know what is combination probabilities. We used to study this in our schooling, right? So this is the same mathematic, but over here you simply need to solve it for a larger number, right? And if we take a look at the constraint says that n can be as large as 1000 and r can be 800. So let's understand the first. Let me just give you the glimpse of what the formula was for n combination R. For n combination R. So basically, this was n factorial upon R factorial into n minus R factorial, right? So this was the formula to find the uh, n combination R. Hello, Abhilash. Hi. Hello, Bhumi Singh. Hi. So basically, this is how you used to find out the uh, just a minute. Okay, my screen is visible, no? Because I won't be able to see. Okay. So this is how you find the value for NCR. Let's say according to the question, input test case number 1. Let's try to find out the value for 3 combination 2. That is going to be 3 factorial, 3 into 2 into 1, and r factorial, 2 factorial, it will be 2, and n minus r, 3 minus 2 is equal to 1 factorial. So this comes out to be 2, 2, and this comes out to be 3, right? So 3 combination 2 comes out to be 2. Similarly, let's take 4 combination 7. Is it possible? 4 combination 7. This is not possible, right? So this means that you are trying to say that how will you select, in how many number of ways can you select 7 items if you are given only 4 items, but that's not at all possible, right? So for such, the answer will be equal to 0. If we have a look regarding this kind of cases, you can observe the second example says n is equal to 2 and r is equal to 4, right? So that means 2 combination 4. Can we do that? No, we cannot, right? So the answer comes out to be 0 in that case. I hope this makes you clear. So basically, this needs to be done. So now, what can you do? Like, how can you solve this question, right? We need to understand that thing. So basically, if I discuss the brute force approach, like anyone from the audience, do you have any kind of doubt in this explanation part? I guess the problem statement is pretty uh, clear enough, right? So for the brute force approach, we can follow the same process, and we can try to find the answer with the help of this formula, that is n factorial and r factorial and n minus r factorial, right? So among these three different values, n factorial, r factorial, and n minus r factorial, which value will take most of the time? The value n factorial is going to take most of the time, right? Because for feasible answer, the value of n is going to be greater than or equal to r. So n will be the largest one every time, right? So overall time complexity of the approach in which you try to solve it using this general formula comes out to be n factorial, and this is too much, right? It's not at all acceptable. So till now, was it clear? Any doubt till now? Yes or no in the chat box quickly. Plus one in the chat box will help me a lot. And are you guys following the series of uh, 21 days code camp? There is a parallel series going on Geeks for Geeks channel. You can follow over there as well. I do take sessions over there. Okay. Last section. Okay. So the last part was about the brute force approach. In the brute force approach, what can be done? So in brute force approach, I can simply apply this formula and get the value for n combination r. But what about the time complexity of this approach? So what will be the time complexity over here? How many values are required? I require There is a requirement of n factorial, r factorial, and n minus r factorial. So basically, all this value is nothing but factorial, right? I need to find the factorial of all these values. So which factorial is going to take most of my time? It is going to take around n factorial. N factorial is going to take most of the time. It is going not going to take n factorial amount of time, but it will be like order of n, something like that, right? So this formula is going to take much amount of time, and the multiplication which you will be doing is going to go beyond the range as well. If you keep on multiplying, the larger value will be 1000 into this into so and so forth. So it is going to take much amount of time, right? And this calculation will be very much lengthy, and it is going to take much amount of space. Variables will not be able to handle such huge number. That is the reason it is mentioned in the question that apply modulo 10 to the power 9 plus 7. Okay, the answer can be large enough. So that was all about brute force approach, but I don't want to apply brute force. I need it more, let's say, better than that, right? Because over here, if you observe carefully, expected time and space complexity comes out to be order of n into r, and space complexity they are expecting is order of r. Okay, so I need some kind of modification, and I need to achieve this time complexity. So let's observe few of the things, and uh, let's conclude and let's understand how we can optimize it. Okay, so that was all about brute force approach. Now let's see approach number one. Let's see the other approach. So what I'll be doing, we know that for n combination r, for how many different values can I find n combination r? I can find the value of n combination r where r can start from, r is from 0 till n. R belongs to 0 till n, right? From 0 to n. What I'm trying to say is that for 4 combination, I can find out 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, and I can get 4C4. But I cannot find the value of 4 combination 5. It is not possible for r. So the value of r can start from 0 and it can go till n. So what will be the value of this 4 combination 0? That will be 4 factorial upon 0 factorial into 4 minus 4, 4 minus 0, that is 0, 4 factorial. It will be equivalent to 1. What will be 4 factorial? 1. I'm just simply calculating these values so that we can observe something. Okay, so over here I'm trying to give you an observation. 4 combination 1, that is going to be 4 factorial, 1 factorial, 4 minus 1, that is 3 factorial. Okay, so over here 4 into 3 factorial will be there. So what I'll be doing, instead of 4 factorial, I will remove this and this. It comes out to be 4. Now 4C2, what will be its value? So that is going to be 4 factorial into 2 factorial into 4 minus 2 is going to give you 2 factorial. So right over here there would be 4 into 3 into 2, and over here 2 into 2. So this comes out to be 6. Now 4 combination 3, if you find the value of 4 combination 3, it is going to be equal to 4. Let's check. 4 combination 3 factorial into 4 minus 3, 1 factorial. So that comes out to be 4 into 3 factorial divided by 3 factorial, and the value is 4. Now 4 combination 4, this is again going to give you what? It is going to give you 1. Okay, so now that was all about when the value of n was equal to 4. Now let's check it for different value of n. Now let's say if n value is equal to let's say 3. So that is going to be 3 combination 0, 3 combination 1, 3C2 and 3C3. Let's try to find the value. I'm writing down different combinations for different values of n because I want you to observe one thing. Okay, there is a clear observation. Pay attention, you will be able to understand it very nicely. So 3 combination 0, that is going to be 3 factorial, 0 factorial, 3 factorial, that is equivalent to 1. Similarly 3 combination 1, that will be 3 factorial. Are you guys able to keep the pace, yes or no, or am I going too fast? Can I know from the audience, am I going too fast? Just a quick confirmation from anyone. See, if you are not able to cope up with the calculation, no, don't worry. The observation is in this line. The observation is in this line. Okay, so I'm just calculating the value. So this is 3 factorial, this is 1 factorial and 2 factorial. So this comes out to be equivalent to 3. Now 3C2, what is the value of 3C2? Do not focus, no importance on calculating the factorial. 3 factorial upon 2 factorial into 1 factorial. Okay, so this is again going to give me 3, and this value will be equivalent to 1. So now I have found the value of for n is equal to 3, I have found combinations, and for n is equal to 4 as well. Okay, so over here if you observe carefully, see 4C0 and 4C4 are same. Similarly 4C1 and 4C3 is same, and this is remaining as it is in between, right? Now for n is equal to 3, you can observe the same thing. 3C0 and 3C3 is same. 3C1 and 3C2, both of them are having same value. So over here, if you take nCr is similar to what? If I am saying that n is equal to 3, c remains as it is, r is equal to 0. And 3c0 is similar to what? It is similar to 3c3. So basically, if you find the value of nCr, it will be equivalent to what? It will be equivalent to n combination n minus r. If you observe, if I am saying that this is 3c3, it will be equivalent to what? 3c3 minus 3, it will be equivalent to 3c0. And that observation is pretty much clear from this part. This is 3c0 and this is 3c3. Okay, so every time for any value of n, if you try to find the combination, then this value remains same. This is going to have similar kind of value on both the side. Pascal theorem we can apply. Yes, exactly. Exactly, Amit Ranjan. Yes, exactly. You are correct. Okay. So now what I'll be doing, let's try to create a Pascal's triangle. Okay. So I have found the value for n is equal to 4. Let's copy this. So this is 1, 4, 6, 4, and 1. This is for 4. Now let's write down for 3. For 3, what was the value? 1331. For 2, what will be the value? So over here, this will be n combination 0, this will be n combination 1, this will be n combination 2, n combination 3, n combination 4, and so on. And over here, this will be containing the values of n. Okay, and it goes on and on. So now this will be 2 combination 0, it will be 1, 2 combination 1, 2 factorial, 1 factorial, 2 minus 1 is 1 factorial, it will be equivalent to 2, 2 combination 2, it will be equivalent to 1. And now for 1, doing the same thing, 1 combination 0, what will be the value of 1 combination 0? It is going to be equivalent to 1. And 1 combination 1 is also going to be equivalent to 1, right? 1 factorial upon 1 factorial into 0 factorial. So now I can do one more thing. I can find for n is equal to 0 as well. For n is equal to 0, I can get only one value, that is 0 combination 0. It will be equivalent to 1, right? So let me get some space over here. Okay, and this is 0 and this is 1 over here. Now let's say the question was to find the value of, let's say, 4 combination 1. Basically the question was asking you to find out this value, what is 4 combination 1. Although this is a very simple calculation, but over here let's take 4 combination 1. If this was the thing that question was asking you to find, then how can we find with the help of least effort, right? We don't want to apply much effort in order to solve it. So what I can do, I can give you one observation, that I want to find 4 combination 1. So I can start from n is equal to 0, and eventually for n is equal to 1, n is equal to 2, 3 and 4, and over there I will be able to reach at 4 combination 1. So let's see how we can achieve it. So basically what I am trying to observe, over here you can observe that n combination r and n combination of n minus r, both of them are having equal or same values, right? So basically, and I will explain you what was the reason behind finding this observation as well. Okay, how will this observation help us? Oh, Jethalal, technical Jet here. Okay, thank you, Jethalal. So basically, So basically, now over here, what we will, okay, so I know I need to find the value for 4 combination 1, right? So for 4 combination 1, what can we do? I will be helping you to start from n is equal to 0. I will be starting for n is equal to 0, then n is equal to 1, n is equal to 2, and n is equal to 3. So basically, what I'm trying to say is that for finding this values, for finding different combinations for n is equal to 4, I can take the help of n is equal to 3. I can take the help of this values. Okay. Now for finding the this values for n is equal to 3, I can take the help of this value. Now for finding all the values for n is equal to 2, I can take the help of this values. And for this, I can take the help of this values. Okay, now if I have this values, and obviously I can get n combination r or n combination any value of r, right? So how can we achieve it? How can we find the next array or next values with the help of the previous value? So let's see. So over here, at the end, let's imagine a 0 is present. Everywhere I have placed 1 0. So now let's say this is initially what I have. For n is equal to 0, I have one value that is representing 1. So you can observe over here for n combination 0 will always give you the answer 1. It will always give you the answer 1, right? It will always give you the answer 1. So what I need to work on is n combination 1 till n combination r. I need to focus on this values. So now if I add 1 and 0, I can get this value. 1 plus 0 will be equivalent to 1. So I have all the values for n is equal to 1, because this one will be as it is, because n combination 0 will be equivalent to 1 always. So I needed one extra value to be found, and I found it in this manner. What I did is 1 plus 0, that will give me the newer value for the upcoming value of n. Now for n is equal to 2, I am going to do the same thing. That is what I am going to do. I will start from, let's say over here, the value I am saying is r is equal to 0, r is equal to 1, 2, 3, and 4. So I'll be adding this value. Now I was trying to find the value for n is equal to 2. So what I'm going to do, let me erase this part, make it little bit clear. So I'll be adding this 1 to 1, and I'll be getting the value 2. Now I'll be adding this 1 and 0 and get the value 1. So in this manner, with the help of values of 1, I have found all the values for n is equal to 2. Now let's see for n is equal to 3. Can we do the same thing? So starting from r is equal to 1, we'll start the iteration part. Okay. So let's start the iteration part from r is equal to 1. So from r is equal to 1, adding 2 to the previous value, I'll be getting 3. Now adding 1 to the previous value, I'll be getting 3. Adding 0 to the previous value, I'll be getting 1. Right? Are you able to observe this pattern? Yes or no in the chat box? A quick +1 in the chat box if you guys are able to see this pattern. Are you guys able to understand this part? Is it making sense? A +1 in the chat box. Okay, I'm waiting for your replies. You can write down. Okay, thank you, Rishit. So similarly for n is equal to 4, I'll be doing the same thing. Now, starting from r is equal to 1, starting from r is equal to 1. I know that this is my value which I'm looking for. Okay, so starting from r is equal to 1, 3 plus 1 will give you 4, 3 plus 3 will give you 6, and 1 plus 3 will be giving you 4, and 0 plus 1 will be giving you 1. So in this manner, I have found all the values for different n as well, right? So now just so now what I am going to do, somehow I will be finding the value for n combination r by taking the help of previous values. Okay, and over here if you observe carefully, these values are not at all needed. See, this part is already present in this part, right? So all the values after this are not at all needed, because if you want to find, because of this combination, because of this observation, that n combination r is nothing but it is equivalent to n combination of n minus r, because this value is going to be same always according to our observation. So why to worry a lot and find out the other values, right? We need to save some space as well, and our time is also, like, we also need to optimize our complexity, time complexity. So basically, what I'll be doing, let's say I want to find the value for n combination. Let's say n combination one. Let's add one more value. Let's try to find for n is equal to 5. Okay, and then we will find some value of 5. Okay, so at the end over here, imagine there is a 0. Extend, let me extend this line. Now let's start. 1 will be as it is. So for the next value, 4 plus 1 will give you 5. 4 plus 6 will give you 10. 6 plus 4 will give you 10. And 4 plus 1 will give you 5. And 1 plus 0 will give you 1. So this is how I'm able to find the value. So now let's say our question was try to find the value for 5 combination 2. Let's say this is the question. Okay, let me put it over here. 5 combination 2. So how will we do that? So for that, what I'll be doing, I will be creating an array. I will be creating an array, and its size will be equivalent to the value of r. Basically over here r denotes 2. So basically what I'm trying to do, I'm trying to store all these values, and combination, I'm trying to store all these values in an array. So basically I need indexing starting from 0 and till r. The indexing should go till r, right? If you guys are having any doubt in between, do mention it. Okay, I will read down in the chat box. Okay, so I'm basically trying to store all these values starting from n combination 0 till n combination r. I want to store all these values in an array. So I have taken an array, and its size not will be equivalent to r plus 1, because I'm starting to solve for starting from 0 till r, right? So over here r is equal to 2, so I have created an array of r plus 1 size. So I have indexes 0, 1 and 2. So now I will start for different values of n, starting from n is equal to 0. So this initial condition, we know that for n is equal to 0 there is only one combination possible, 0 combination 0. And for that we know the answer as well, that answer is going to be 1. And also any combination 0 will always be equivalent to 1, so I can take this part as an initialization step for the array. Okay, so this is basically, imagine, an initialization step for the array. And now let's start with n is equal to 1. Now for n is equal to 1, what I need to do, I need to find all the values starting from r is equal to 1 till r is equal to 2. That means this many values I need to calculate if it is possible. And we know that r value can never exceed the value of n. N will be greater than or equal to r. Now over here n is equal to 1, and what can be the maximum value of r? Maximum value of r can obviously be equivalent to 1. So I need to fill only this many values. And how will I fill these values? As I mentioned, you simply need to add the previous value. 0 plus 1 will give you 1. So this is the same thing. What I'll be doing, let's call this array as the dp array. So dp of I is nothing but dp of I minus 1 plus dp of I. Okay. So over here, or I can say instead of I, you can imagine there is alphabet R, right? So now over here, need to find this value. So 0 plus 1 will give you 1. So replace it. Now no extra values can be found because R cannot exceed the value of n. Now what is the value of n? Let's try for n is equal to 2. Now for n is equal to 2, what I need to do? I need to find all these values. So what I'll be doing, I will be starting from this position. So 1 plus 1 will give you 2. And over here 2 plus 1 will give you 3. Okay, so basically we need to start from end. Okay, so just a minute. So basically starting from this end. Okay, I started from this end. And now what I'll be doing, I need to add two different values. So 0 plus 1 will give you 1, and over here 1 plus 1 will give you 2, right? And you can observe in this array as well, it is containing 1 to 1, right? So now let's start for, now let's find the value for n is equal to 3. Okay, for n is equal to 3, you know that n r value can be as large as 3, right? But over here we simply need to take the value of r till n, till 2, right? Because this is the last value till which we need the answer. We don't need extra things, because our question is to find what, as our question is to find 5 combination 2 where r is equal to 2. So again, starting from the last point, from this point, 2, adding this to value, 2 plus 1 will give you 3. So replacing it, and 3 will be placed. Now let's find for this will be 2 plus 1 will give you 3. So over here 3 will be there. You can observe this was for n is equal to 3, and you can observe 133 is present over here as well. Now for n is equal to 4. Now for n is equal to 4, let's try to find the values. Let's start from the last point. Starting from here, 3 plus 3 will give you 6. Now for this, 3 plus 1 will give you 4. You can verify over here for n is equal to 4. You can see 1, 4 and 6 is the value. Now for 5, n is equal to 5. Okay, here is our final thing. Starting from last point, this is 6 plus 4 will give you 10. And for this, 4 plus 1 will give you 5. And we have final answer, and our final answer will be at the last index, obviously, right? Because we need to find for n combination 2, and it is equivalent to 10, and we can see and observe over here as well. Was the observation part clear to everyone or not? Yes or no in the chat box. Any doubt, anything? Was it clear? Any confusion in any of the part? Okay, so now basically I need to create an array of size r plus 1, and I need an initial step. So initialization step was to initialize the first index, that is 0th index, with 0, I mean with 1. Can you take one more example? Okay, so for one more example I'll take a smaller example. Let's try to find the answer for let's say 4 combination 2, 4c2. Let's try to find for 4c2. Okay, 4c2 I want to find, and what is the value of r value is equal to 2, n value is equal to 4. So what is the first step? First step is to create an array of size r plus 1. 2 plus 1 will give you 3. So this will be 0, 1 and 2. I have created an array. Now what is the initialization step? We can observe over here, n combination 0 is always going to be equivalent to 1. Over here, this is not index, it is different value of r. you have to take it in this manner. Do not see them as an index. Okay, so we know that any value of n combination 0 will always give you 1. So now I will start for n is equal to 1, and eventually I will end at n is equal to 3. So what I'm going to do, I'm going to find one combination 0 and one combination 1. Now I'm going to find two combination 0, two combination 1, and two combination 2. I'm going to find three combination 0, three combination 1, three combination 2. And at the end, I'm going to find four combination 0, four combination 1, and four combination 2, because this is what I need. And this can be obtained by adding this two part, by adding these two values. And over here, in order to get this 3c1, you need to add these two values. In order to get 3c2, you need to add these two values. Okay, so that is the reason, and this is where, and that was the reason behind starting for different values of n. Now let's start. Let's start for n is equal to 1, and r value cannot be greater than n. N will be greater than or equal to r. Okay, now it's clear. Okay, okay. I hope your doubt was clear. So let's quickly end this part. I mean, get it solved. So now I need to find for this. So over here, initially 0 is present. So 0 plus 1 will give you 1, and 1 will be placed. Now let's find for n is equal to 2. So I need to start from n. 1 plus 0 will give you 1, and 1. And over here, for this, 1 plus 1 will give you 2. Let's find for n is equal to 3, starting from the last index. So that would be 0. 1 plus 2 will give you 3, and 2 plus 1 will give you 1. 2 plus 1 will give you 3, sorry. Will give you 3. Now for n is equal to 4, you need to find, start from the end. 3 plus 3 will give you 6, and 3 plus 1 will give you 4. And over here, here is your value of n. Where is your nCr? It is at the end, and it is equivalent to 6. Now I hope everything was clear to you. Okay. So basically, in this manner, we need to proceed further. And what will be the time and space complexity? Over here, I have created an array of size r plus 1. And after that, over this entire array, I am iterating how many number of times? I am iterating n number of times. So the overall time complexity comes out to be order of n into r. Now, what about the space complexity? I have used an extra space, so the space complexity will be equivalent to r. So this is my time and space complexity. Okay. Now let's try to move to the coding part. If you have any doubt, do mention it right now. Okay, so let's see the coding implementation for this same. So what do you guys want? Do you want me to code, or I already have the solution? So basically, let's go through the solution quickly, and let's clear the things. Okay, let's code it from beginning. Okay, so let's start from the beginning only. Okay, so this is the solution for this question. Okay, so I want the voting from you guys. Do you want me to code, or do you want me to go through the solution? What is your preference? Rishit? Okay, so I'm going through the coding implementation part, which I already done. Okay, so now here is our function nCr, in which we need two arguments are there, the value of n and the value of r. Now this is the array in which I'm going to store the combinations value, right? And it is having size r plus 1. And I have iterated over this array and initialized each and every value to be equivalent to 0. But as I'm using Java language, you can ignore this part because in Java, arrays are already okay. Rishit. Arrays are already initialized with default values. And ignore this part. So now here comes the top row of Pascal triangle, but I'll call it as initialization. We know that n combination 0 is always going to be equivalent to 1. So C or combination of 0 will be initialized as 1. Now this is different value of n. Okay, I'm finding for n is equal to 1, 2, and so on. So I'll be starting from n is equal to 1 because for n is equal to 0, that is C 0 combination 0 has already been done. So I'm starting the iteration for from I is equal to 1 and going till value of n. And over here there is another for loop which is starting from the last index and going to the index number 1. Over here, if you observe carefully, I have used something as minimum of I comma r. Okay, I'll explain that part. But over here, imagine for now, I'm iterating from the last index of the array till the index 1. And over there, what is the process that is taking place? The process is that the jth at the jth position, I'm adding the current value and combination of and the addition of j minus 1th value. Add both of them and apply modulo 10 to the power 9 plus 7. Okay, so now I applied both the things, and after completion of this entire for loop, whatever is the value present at the rth index is the output. Okay, so the code is very much simple. It is exactly what we did in order to solve the answer. So now let me explain this part, minimum of I comma r. Let me open this again. Okay, so basically, what was the reason behind running the inner for loop from minimum of r comma I? Let me explain. So we know that if you observe over here, okay, over here in this observation, you can observe, let's say, for 4, if I am able to find 4 combination 3, and over here the value of r is equal to 3, but I cannot do the same thing for 2. I cannot find 2 combination 3. Here the value of r does not remain same. If I keep it same, then answer does not exist. Similarly, I cannot find 1 combination 0. Is it making sense? I cannot find anything for any value of r which is greater than n. For this kind of condition, now no answer exists, right? So over here, we know that the iteration of n starts from 1. And let's say we are given, let's say, 5 combination 3 in this case. If we are given 5 combination 3, now in order to find 5 combination 3, I'm going to find what? I'm going to find 1 combination 1, but I cannot find 1 combination 2 and I 1 combination 3. The last two index values cannot be filled because it is not logical. So what I am going to do over here on the values of I, the loop which is running as a loop variable I, on the different values of n, the loop which is running, that is the outer for loop, which is running on different values of n as a loop variable I. Over here in the code you can observe. This is the loop variable that runs on different values of n. It has loop variable I. Now this for loop over here denotes that minimum of I comma r. Minimum of I comma r, what does it mean? That means if the value of I is equal to 2 and if I is equal to 2 and if r was equivalent to 3, over here I was finding 5 combination 3 and the r was equivalent to 3. It is not at all possible that I can find 2 combination 3. So I need to iterate on the smallest part of I and r. I hope this is making you a little bit. I hope this is making it sense. Okay. For some of the values of n, you cannot find n combination r. For every value of n, for any r, it is not possible. And that is the reason I need to handle it in this manner. Okay. Now let's try to quickly compile and run and see what is the output. And compilation is completed. Now let's try to submit and see the acceptance. And we can see the problem was successfully solved. Right over here, one condition can be added. You can add this condition as well, that if r is greater than n, then answer does not exist, return 0. This can be added as well. Okay. And what will be the time and space complexity? We already discussed n into r. This loop will run n number of times. This will run r number of times at max. N into r is the time complexity. And space complexity is equivalent to order of r. Now you can tell me what kind of doubts do you have? Anything related to this? Any doubt from anyone? Okay, so that was it. And can we can you, can we use the property of nCr equivalent to nCr? Yes, you can use that property as well. For example, 5 combination 4, we will need an array of size 4, but you can find the value of that as 5 combination 2 as well. 5 combination 1, right? You can find 5 combination 1. Yes, you can do that exactly. Yes, you can apply that modification as well. Okay, but at the end over there as well, the space complexity is going to be order of r only, right? It will be lesser than r, but how much lesser? N minus r, or you can say n as well. Okay, so it will be around r only. It will not give you a major uh, difference in space. Okay, so that was it for today's session. I hope you really enjoyed this session. If you really enjoyed this session, then do like this video and share it with your friends. And let's meet in the next session. Okay, yes, average case will improve. Okay, thank you and good night, everyone. Bye bye.